Alright guys, this is the notes for 3.5, solving exponential and logarithmic functions. When we're solving exponential equations, there's two situations you come across. We're going to have situations where bases play nice, meaning that we can write both sides of the equation in the same base. So when that's true, we can apply a concept called 1 to 1. And so if 2 to the 2x plus 1 equals 2 to the 5th, that means those exponents must equal each other. So 2x plus 1 must equal 5. And we can solve that. So if we subtract 1, we can subtract 1. We get 2x equals 4, or x equals 2. Okay. So here, now here we're not as lucky. It's not just written as nicely as 2 and 2. It's written as 2 and 16. But we can rewrite 16 as 2 to the 4th. So here we can just rewrite this as 2 to the x equals 2 to the 4th, and then I can apply that same concept and say that, okay, x equals 4. Getting a little more challenging here, 1/9 and 27. 1/9, well that's 3 to the negative 2nd, and 27 is 3 to the 3rd. So I'm going to replace those values with 3 to the negative 2nd, 3 to the 3rd, but I'm still going to raise that to the power of 2x. So I'm going to end up with 3 to the negative 2nd equals 3 to the 6x, meaning that negative 2 equals 6x, which when we divide by 6 means that x equals negative 1/3. Okay, so the idea with this one, you'll see this in your homework, is that you're going to rewrite it as the same base. Okay, well, what about when they don't play nice? So we can't raise 5 to that power with the base of 2, right? We can't write these same bases. So what we do here is we rewrite it as log. So we're going to say log base 2 of 5 equals x, and this is something you can evaluate on the calculator, right? You can go on your calculator here, you could go to math and then log base, and you can plug that in. Okay, we'll keep going here. So same idea, we're going to have log base 5 16 equals x minus 3, and then we'd solve that for x, so we'd get x equals log base 5 16 plus 3. Again, you would just evaluate that in the calculator. And here, same idea, it's ln 7 equals negative x, divide both sides by negative 1, we have negative ln 7 equals x. Okay, so those are the two exponential types. Then we have log types. So logs, we got to use those properties that you learned in your previous lesson. There's again two situations, and this is similar to the previous page. This is that same 1-to-1 concept where if we have the same log base on either side, then x must equal y. Okay, so here we can combine these, right? We can say log 3 minus x equals log, and then I can multiply the inside here, x squared plus x. So that means that 3 minus x must equal x squared plus x, which means that 0, we're going to solve this by setting equals 0, x squared plus 2x minus 3, factors are x, x plus 3 and x minus 1. So my solutions are x equals negative 3 and x equals 1. So the difference with log versus exponential is that when you solve it at the end, because logs have domain restrictions, right? Logs cannot be, the input cannot be 0 or negative. We have to make sure that these work, so we go plug them back in. And okay, if I plug in the 1, it's all going to be okay, but if I plug in that negative 3, I'm going to have the log of a negative number. So this is my only solution because this is extraneous. Okay. All right, here, another way we can solve is when logs are isolated, we can rewrite them as an exponential. So it's that easy. 3 to the 4th equals x. You'll see these in your homework, and the steps are really straightforward. It's one is isolate the log, and two is rewrite as exponential. So at this point, hoping this has made some sense, go start that group work activity, and when you're done with that, check out the answer key the video for the group work. All right.